Howdy, and welcome to my video on exponential and logarithmic equations. So this video will just be about solving equations that involve exponential equations, so when the variable is in the exponent, and logarithmic equations, which is when you have a logarithm somewhere. Okay. These problems are taken from the Virtual Math Learning Center. A link to those problems we put in the description. Okay. So let's start with question 1. So we're going to solve for x and make sure the solution makes sense. So e to the x equals 5 halves. Remember that e is not a variable, right? E is just a constant. So in this case, right, our variable is the exponent, right? And to isolate this, exponent, we need to take the natural log of both sides. Remember, natural log, right, is the is logarithm base e, and to undo a base, so to say, right, you use logarithm. So natural log both sides, same base, so these cancel, and you have an x remaining, and that equals your natural log 5 halves. Okay, so this is your answer. Your x equals natural log 5 halves. Now to answer, or to check, right, e to the power of natural log 5 halves. So we know that if the log and the base, if the base of the log and the actual base are the same, they just cancel out. So you get 5 halves, and it equals 5 halves. So this is all good to go. Okay, so for number 2, again, we are solving for x. So we have 3 to the x plus 7 equals 15. We want this by itself, so we can take a log. So I'm going to subtract 7 from both sides and get 3 to the x equals 8. And now we can take the third log, right? So log 3, right? 3x equals log 3 of 8. Earlier, right? Same base, so they all cancel. And you get x equals log base 3 of 8. Okay. That is my answer. And we check, you'll see that we get log 3 to the power of log 3, 8. These cancel. Let me write out the rest. Right, plus 7. So this is 8 plus 7, and it gives us 15, which is indeed equal to 15. All right, so for number 3, we're once again solving for x. So we have 15 over 100 plus e2x equal 2x equals 3. Okay. Now I know that 3, right, it's 15 for 5. So I'm going to write 15 over 100 plus e2x equals 15 over 5. Since these two are equal, right, that means these bottom two are also equal. You don't like this trick, or it doesn't work out this easily, right? You can also just multiply by 100 plus e2x, and then you divide by 3, and you basically switch. But regardless of what you do, right, you end up with 100 plus e2x equals 5, right? E to 2x equals -95. And from here, right, you can already tell that this doesn't have a solution, right? Because if you multiply e over and over again, no matter what you do, you get a positive number. So this is impossible, right? for a positive number, there's no way for it to change into a negative. There is no solution. The more formal way I say this is, okay, so from here, from like this last step, let's take the natural log of both sides. Actually, yeah, natural log. So natural log -95. And if you look at this one, right, this is log base e -95. This is a positive base, right? You're telling me that e to some power gives you -95, but again, that's nonsense, right? E times e blah 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 gives you a positive number, right? No matter how many times you root the e, right, still a positive number. And 1 over e times whatever, still a positive number. So no solution for number 3. Okay. Number 4 says to solve the following equation for x and to check your solutions. So again, there's a solving question. And now if you look at this, right, we can see that we actually do have what looks to be like a quadratic, right? This exponent is double of this exponent, and the bases are the same. So what I'm going to do is I'm going to try substitution. I'm going to say y equals a to the x. This means y squared is equal e to 2x. When I rewrite my equation, I will get y squared plus 7y minus 18 equals 0. And from here, we can solve like a quadratic. We could use quadratic formula here, right? Because we're solving for x, or for, in this case, for y, right? So negative b plus minus square root b squared minus 4ac over 2a. This is negative 7 plus minus square root of 49 minus 4 times 1 times negative 18. All that over just 2. Get negative 7 plus minus square root of 49 plus 72 over 2. This is negative 7 plus minus square root of 121. Yes, over 2. This is negative 7 plus minus root 11, or not root 11, 11 over 2. And we can divide this up. We get negative 7 plus 11 over 2, which is 4 over 2, which is 2. And we get negative 7 minus 11 over 2, which is negative 18 over 2, which is negative 9. Okay? So we know we have y equals 2 and y equals negative 9, right? So these are our solutions for y, but we have to put back in the e to 2x, right? So this becomes e to the x. E to the x equals 2, right? You get natural log both sides, and you get x equals natural log of 2. This makes sense. So this is one answer. For y equals negative 9, we get e to the x equals negative 9. Again, right? Positive base, but we have a negative answer. So this is no solution. Now we can check our work, right, by plugging it in. So e to the power of 2 times natural log 2 plus 7e to the power of natural log 2, okay, minus 18. Now this equals e natural log 4 plus 7e natural log 2. And this 4, right, comes from 2 squared because we moved this 2 here as per the exponent law. Minus 18. the e's cancel out with the natural log. We get 4 plus 7 times 2 minus 18, which is 4 plus 14 minus 18, which is 18 minus 18, which is 0. And indeed, that is what we want. Okay. Number 5 is to solve for x, but this time we have a logarithmic equation. So log 5, right, 4 to the y equals 3. Now remember, when we convert a logarithm into a regular equation of other, right, we take the base. So this is the base, right? Base, exponent, and this is your answer. So base goes here, exponent goes about here, and my answer goes right there. I'm going to use different colors. So pink for the base, so 5, right? And then our exponent goes right here, so 5 to the thirds, and equals to the stuff in parentheses. 5 cubed is just 125. Then we get y equals 125 over 4. And when we plug it in, right, so log base 5 of 4 times 125 over 4. This is equal to log 5, 125. And we're asking ourselves, 5 to what power gives us 125? The answer is 3. So when that equals 3, so that is indeed a correct solution. Okay. Whoops. Now we're solving this for x, and we're checking for extraneous solutions. Okay. So first things first. Okay. So I am going to combine these two together. Excuse me. And we get where's it? We get log 5 x plus 2 x plus 3, okay? And the other side, you get log 5 of 6, okay? Now we can raise both sides. We can cancel out these logs by using a 5, okay? So put a 5 here. So essentially I wrote 5 log 5, right? Then the x plus 2, x plus 3, which equals the 5 log 5 of 6. These cancel out, right? Same base. So you get x plus 2 times x plus 3 equals 6. From here, it's just algebra. We FOIL x squared plus 3x plus 2x plus 6 equals 6, right? These 6's cancel, and we combine like terms. So we would get x squared plus 5x equals 0, okay? You have x plus 5 equals 0. And when we solve this, sorry, I'm thinking for a sec, so sorry for the pauses. When we solve this, we get x plus 5 equals 0, x equals -5. And for this one, we get x equals 0, which is just x equals 0. And now we need to plug these back in, okay? So for x equals -5, I'll plug it into the first one, okay? And I'll notice that when we do for the first term, we get log 5 -3. Again, this is a problem. We have a positive base and a negative argument. This does not work. When you try to solve this, there's no solution. So like I said, no matter how many times you multiply a positive number by itself, it's all positive. So you only get a positive solution, a positive answer. So there's no exponent. There's no amount of times you can multiply 5 by itself to get a negative answer. So x equals negative 5 is actually an invalid solution. Okay. What else? X equals 0. So we have log. So with the 0, right? That means we just ignore this part. And we have log base 5 of 2 plus log 5 base 5 of 3 equals log base 5 of 6. We can use our multiplication rules. All right, so log of 5 2 times 3 is 6 equals log base 5 of 6. These are the same, and we're good to go. And that means my answer is x equals 0. All right, number 7. We're solving for x again. So first things first, I'm going to combine these two into 1. As we're adding, right, we can multiply the arguments together to get log base 5 of x times x plus 4 equals 1. Okay. Notice that, so we had 5, so we have the base here, 5, the exponent, 1. And this will equal to our argument, x times x plus 4, right? And I should write it in purple. X times x plus 4. We can FOIL out the right side, and we get x squared plus 4x. We subtract 5 on both sides, and we get x squared plus 4x minus 5. We can factor that, right? Two numbers are multiplied up to negative 5, add up to 4. That would be positive 5, negative 1. So 0 equals x squared minus x plus 5x minus 5. This is just x times x minus 1 on the left, plus 5 times x minus 1 on the right. Take out the common factor, add everything else. And from here, we have solutions, right? X plus 5 equals 0, which means x equals negative 5. X minus 1 equals 0, which means x equals 1. Okay, so for x equals negative 5, I'm going to plug into the first one, right? Log 5 of negative 5. This is no solution, right? Positive base, negative argument, so this does not work. But for x equals positive 1, we get log 5 of 1 plus log 5 of 1 plus 4, right, equal to 1. Log 5 1 is always just 0, right? Because this is the argument, right? 5 power what is 1? That what is 0. And then you have log 5 to the 5 of base 5 of 5, right? These are the same, right? So you get 1 equals 1. So our answer is x equals positive 1. All right, for number 8, we're going to be solving for x. So again, same base, so we're going to combine these. Log 3, and we get x plus 2 on top because it's positive, right? There's a plus sign here. And a minus sign here, so we have the 2x on bottom. And we'll make that equal to 4. We rewrite this as an exponential. So 4 cubed equals x plus 2 over 2x wait, not 4 cubed, sorry. 3 to the 4th. 81, and then equals x plus 2 times 2x. We'll multiply both sides by 2x. And we get 162x equals x plus 2. We can subtract x from both sides, right? Get 161x equals 2. And then we divide. That should be our answer. I am not particularly a fan of plugging this back in. But we can. Okay, so going off the original, right? So you have log of, that's gonna be a doozy. 2 over 161 plus 2 over 2 times 2 over 161. Okay. So we're gonna check the fraction here. So we have 2 over 161 plus, we'll do 2 times 161 over 161, right? And it's all over 4 over 161. Trying to think how. Okay. We multiply top bottom by 161, and we get 2 plus 2 times 161 over 2. Okay. We can divide everything by 2, so we get 1 plus 1 times 80. Wait, 161. What did I go wrong with? Yeah, it's just 1 times 161, sorry. Okay. And we get, oh, I'm missing something. Oh, yeah, it's a 4 on bottom, sorry. Divide everything by 2, and we get this over 2. We have 162 over 2, which is 81. We plug that back in. Log base 3 of 81. 3 power what is 81? My answer is 4. And that is indeed our answer. Alright. Number 9. So, we are solving again for x. We all have the same base, okay? So, what I would do is move everything to the left side first. It's kind of weird, but it hopefully, at least for me, it will make sense in a bit. So, I have log 6 x minus 12 minus log 6 of x minus log 6 of, what's it, x minus 6. Alrighty. And this all equals 0. Okay. We combine these, this whole left side, and we get log 6 of x minus 12, x times x minus 6 equals 0. I should explain that. So this is positive, right? So it goes in the numerator. Double negative, or these two negatives, so they both go in the denominator. So we rewrite this in exponential. 6 to the 0th power is x minus 12 over x times x minus 6. We get 1 equals x minus 12 for x times x minus 6. We can multiply both sides by the denominator, so we get x times x minus 6 equals x minus 12. We can FOIL, and then we can try, so subtract see, going to subtract x from both sides, and then add the 12. Okay, from here, we can try to factor. We get two numbers that multiply to 12 add up to -7. That is -4, -3. Sorry, I am a bit slow, son. X squared minus 3x minus 4x plus 12 equals 0. Continue up here. We can take out x from the left side. You get x minus 3 remaining. We can take out -4 from the right side. You have x minus 3 remaining. That equals 0. So you have x minus 4, x minus 3. Actually, sorry, let me do it this way. Common factor, we take it out. And we add the rest. That's the most lopsided x I've ever written. X minus 4 equals 0, so x equals 4. X minus 3 equals 0, so x equals 3. Now, we need to check these, right? So for x equals 4, right? Log 6 of 4 minus 12 gives us log 6 of -8, positive base, negative argument. This is no solution. And then for x equals 3, we have log base 6 of 3 minus 12, which is log 6 of -9, positive base, negative argument, no solution. Both our x's are actually extraneous, so we actually have no solution for number 9. And finally, number 10, which is this exponential growth for the k function. So we are given this equation, right? And it's to represent the number of bacteria in the culture after t days. So the first question is, what is the initial number of bacteria? So with our exponential equation, right? Rewrite our y of t for a second. So I'm going to rewrite this as 100 e to the 1/8 times t. Okay. And if you look at our general form, right? We have final population equals initial population one plus growth rate to the power of the time period. So our y of t is the final population. Our 100 is our initial population. Our e to the 1/8 is just the final growth rate, right? And then our t is our time period. And we need to make sure that since the equation is in days, if the question asks for hours, weeks, months, we convert the units appropriately. Okay. So part A is, what is the initial number of bacteria? And I don't know why. Okay. So for A, the initial is given to us already, right? Like I said, it's 100. So it is 100 bacteria. My pen is dying. 100 bacteria. Okay. Now, for part B, actually I can just write the answer in the thing, can't I? So 100 bacteria. Okay, part B is how many after 40 days? So we just plug it into the equation, right? So y of 40 is equal to 100 e, and we'll use the original because it'll be a little faster this way. 40 over 8, right? And this is 100 e to the 5th. That is your answer. So we will have 100 times e to the 5 bacteria. Okay, and after how many days will we have 4,000? Okay, so part C, we have 4,000 equals 100 e, and t divided by 8, right? So we can first do is divide both sides by 100 to have 4d equals e t to the 8. We can take natural log of both sides. So natural log 40 equals t to the 8, because natural log and base e cancel, right? You can multiply both sides by 8 and get t equals 8 natural log 40 days. And that is our answer. 8 natural log, put parentheses, 40 days. And with that, question 10 is done, and that concludes my video.